Youngins, today we're going to discuss how to find all your real zeros. And just to be clear, a zero is simply a place on a graph where your picture or your graph crosses the x-axis, okay? So we're going to look for those. And since we're saying real, imaginary numbers are not part of our answers, all right? Imaginary numbers are not part of our answers. So the way this works is you'll notice that I don't have anything to go off other than this equation. And so I need some numbers that could potentially be zeros, all right? And so the way that works is if we call this P and the leading coefficient Q, what happens is we make a fraction list out of P over Q. Let me list all the factors of 10, which are positive and negative, 1, 2, 5, and 10. All of those are the factors of 10, which is P. Q is 1, and so all the factors of Q are positive and negative 1. What we've done here is listed all the possible rational zeros when we make our fractions here. So let's go ahead and do that. Let's actually divide 1 and positive, negative 1 into all of those. And when you do, you'll get positive and negative 1, 2, 5, and 10 all over again. Now, that's not always going to be the case. Sometimes your leading coefficient is not going to be a 1, and so you would have to divide the others as well. But in this case, when you divide positive and negative 1 into all of those, you still get positive and negative 1, 2, 5, and 10. Now, after you do that, now these are the actual numbers that could be zeros of our graph, all right? So what I would do next is set up synthetic division, where I have 1, 1, 1, negative 9, and negative 10. Remember, with synthetic division, if you are missing a factor, you got to put 0 in its place. So now using a pencil, why? Because I want to erase. I was using a pen earlier. I'm going to try these numbers, each one of these numbers. And remember, that's a positive and negative 1, a positive and negative 2, and so on and so on. So I'm going to start off with a 1 and see how that works. I bring 1 into the box, and I'm going to do synthetic division. Why? Let me pause and explain the process. If I can get this degree down to 2, which means it's quadratic, then I can do the quadratic formula, complete the square factoring. But right now, I'm trying to do synthetic division so that I can bring the degree down. But I need to find one of these numbers that actually give me a 0 for my remainder. And I get a 0 whenever that number here turns out to be a factor. All right, so I'm looking for a 0 as a remainder. All right, so bring 1 down. 1 times 1 is 1. This becomes 2. 2 times 1 is 2. This becomes 3. 3 times 1 is 3. And that's negative 6. And I'm not going to get a 0 like that. So positive 1 is not going to work. So notice what I do. I erase and I start over. This process might be one that you want to do on a scratch sheet of paper because you have to erase several times or redo several times. So what am I doing now? I'm going to try negative 1. Why? Because there's positive and negative 1 over here. So I'm going to try negative 1. 1 times negative 1, that's 0. 0 times negative 1, 0. You add that, negative 1, that's negative 10, and negative 10 times negative 1 is a positive 10, and look, I got a 0. That's exactly what I'm looking for. I'm looking for 0 as a remainder. So what does that mean? Well, since negative 1 gave me a 0 as a remainder, part of my answer is x equals negative 1. Okay? Now, let's keep going. This now means x cubed minus, x cubed plus x minus 10. because the 0 is where the x squared was. So x cubed, x squared, x to the first power minus 10 equals 0. Now I could use that and try to do some solving or something like that, but that wouldn't make sense, guys. It's not sensible. So what I'm going to do is not use this again, or not use it at all. And what I'm going to do is actually set up synthetic division again. Now, why am I doing that? The reason why is because I have a cubed now. I still need to get it down to x squared. That's what I can use. I don't have any factoring skills for x cubed, so I'm going to use synthetic division again with what I have here. Okay? Now, I've already used positive and negative 1, so the next thing I have is to use 2. So I want to try 2. You see what happens when I use 2. So 1 times 2 is 2, and that makes 2. 2 times 2, 4. That makes 5. 5 times 2, 10. And look, I get a 0. Right? So what does that mean? That means this is x squared minus 2x plus 5 equals 0. Okay? So now I have x equals negative 1 and x equals 2 as my solutions, as my zeros. By doing synthetic division, now look what I have left over. You say, aren't you done? No, because now I have this quadratic trinomial that I can actually work, and I can figure out by doing the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. What am I doing? I am trying to find out the other solutions. So this is going to be 4 minus 20. So when I simplify that, that's going to be 2 plus or minus the square root of negative 16 over 2. Now I'm going to stop right here. And the reason why I'm stopping right here is because I am going to get an imaginary number for my answer because I have a negative number underneath the radical. So what does that mean? The only real, notice that's underlined, solutions to this problem is negative 1 and negative 2. Now, at the most, I should get 4 solutions, right? So there's 1, there's 2, and the plus and minus make 3 and 4 of this problem. But again, if I'm asking only for the real solutions, it cannot be an imaginary number. All right? Questions? Any questions? Haha, just kidding. You can ask me any questions. Now, what I'd like to do is show you this. This is Graphing Calculator, and what I've done is I've went ahead and put our function, our original function here into the Graphing Calculator. All right? And so now I hit Graph, and look there. It kind of gives me, a small little picture of what this graph looks like. If you notice, can't you see that this is crossing the x-axis at negative 1 and at positive 2? And if you didn't believe me, you can go to second and trace, and I want to find a 0. That's what we're looking for. Zeros, right? Zeros, roots, solutions, x-intercepts, all mean the same thing. So notice this calculator asked me for a left bound. So if I want to find this one for sure, I want to be on the left-hand side of that point. Well, that's too far. So I hit enter, and then it asked me for the right bound. So on the same point, I want to be on the right-hand side because the calculator is going to do a little estimate. So I hit enter. Now it asks me, do you want me to guess? Sure. Approximate it. Look at what it gives me. Negative 1, 0. I already know what my 0 is right there. And the same thing would go if I did it for the other one. A graphing calculator helps you eliminate. So if you have a whole bunch of these numbers to pick from, then you can kind of narrow it down and you can show your work there based on your graphing calculator. It's a really useful tool. It helps you not have to guess a whole bunch if you have a whole bunch of these like we've done in class. Let's keep going. Number 2. Number 2, same idea. I need to find all the rational zeros. I don't have any to go off of. And so my P is 18, my Q is 1. And so the factors of 18 are plus and minus 1, 2, 3, 6 and 9 and 18. And all of those are over 1. It's nice when it's over 1. Nice and easy when it's over 1. I'm going to go ahead and run through this, running out of time. So all of these right here, I'm not going to rewrite it, are the potential ones, okay? And so what we're going to do, and for the sake of time, what I've done, and you may not have this opportunity, but we can maybe put a graphing calculator on your laptop, is I went and put the equation in, and I hit graph, and I noticed that -2, -3, 1, and what was that, 2 are part of the solution set. So I know several of the answers. So I'm going to try the numbers that they have here. How about +1? I'm going to try +1 in my synthetic division, where I get 1 and 1 and -11 and -9 and 18. I'm going to try 1 to see if that works. So 1 times 1 is 1, that's 2. 2 times 1 is 2, that's -9. -9 times 1 is -9, that's -18. -18 times negative of 1 is -18. And yes, that gives me 0. So I know that x equals 1 is one of my solutions. But again, this is now x cubed. If this was x to the 4th, this is now x cubed. So what does that mean? That means I am going to do another synthetic division. So I'm going to try one of the other zeros. How about -2? -2 was one of them. And how do I know that? Because I went and looked at the graph. How would you know that? You just pick from here, and you keep going until you find one that's a 0. That's -2, 0. And it's -9. That's +18, and again, I get 0 there. And so now I know x equals -2 is one of my solutions. What's left over here? This is x squared minus 9 equals 0, right? That's what I have left, because 0x goes away. Now, what I'm going to do is not quadratic formula, but I'm going to solve by square roots, or you could factor there. X squared equals 9. Take the square root of both sides. You get x equals plus or minus 3. So what does that mean? That 3 and -3 are also your solutions. All right? Okay. This is the last problem that I'm going to try to squeeze in. The factors of 81 are 1, and let me list all these out. All right, so after listing all the factors of 81 and 3, what you will have is all the possible rational zeros would be all of these here, 1, 3, 9, 27, and 81, okay? That's because I divided 1 into each one of those. And the next ones, that's the bell, will be 3 divided into each one of those. This is the first time I've been able to work one like this. So if I do 3 into 1, that's 1/3. 3 into 3, that's 1, so I don't have to rewrite that. 3 into 9, that's 3, so I don't have to rewrite that. 3 into 27, that's 9, so I don't have to rewrite that. And 3 into 81 is 27, so I don't have to write that. So anytime a number repeats, you don't have to rewrite it. And so that's what happened here. I took 1 and divided it into each one of those, but since I have multiple denominators here, each denominator has to be divided into every term or number in the numerator. And so each one of these are potential zeros. That's positive and negative, 1, 3, 9, 27, 81, and 1/3. Positive and negative versions of each one of those. Okay, since I am running out of time, I'm going to go ahead and you try it, and then I'm going and pause it right now, and then I'm going to finish it up. All right, what I did was I went ahead and finished up the problem. I did synthetic division twice after using positive and -3 from my graphing calculator. And then, once I got here, I went ahead and used the cubes. And I actually factored by grouping. You can do that. You don't have to continue doing synthetic division. If it'll work, factor by grouping. And I get these two factors. But notice when you do that, you only get one real solution because you get i's over here. So 3, -3, and -1/3 are your solutions. Either way you did it, if you kept doing synthetic division, you should have came to those 3 answers.